Hey there, this is Mr. Pi. Welcome to another math lesson. Today we're going to be talking about an Algebra 2 topic, inverse relations and functions. If a relation pairs element A of its domain to element B of its range, the inverse relation pairs B with A. So if AB is an ordered pair of a relation, then BA is an ordered pair of its inverse. What's really important in here is that the element A of the original relation is paired with element B. That order, A is paired with B in the original relation, is important when comparing it to the inverse, where you have B being paired with A. The order changes. So when we have an ordered pair, AB of the original relation, then BA is going to be the ordered pair of the inverse. So really important to understand that all we're really doing is switching the order here. The domain for the range, we can see a visual representation of this here in these two mappings. The original relation R, we have four domain values, 1.2, 1.4, 1.6, and 1.9. And we have two range values. Each element of the domain is paired with an element of the range. Here, we switch the domain values and the range values. So we see 1 is paired with two values, 1.2 and 1.4, and 2 is paired with 1.6 and 1.9. So all we do when finding the inverse is switch the domain and the range values. Our first example, find the inverse of the relation M. Graph the relation M and its inverse. Determine if the relation and its inverse are functions. When we do that last part, when we're determining if the relation and the inverse are functions, we want to remember the vertical line test. We'll get to that in a moment. Here, we have the relation M. We have sets of ordered pairs. First ordered pair would be -1, -2. The second ordered pair would be 0 and -1. So x is 0, y is -1. Third ordered pair is 1, -1, 1, -1. And the last ordered pair is 2, -2. So 2, -2 right there. So that's our original function. Now the inverse of that, the x and the y's are going to stay put, but we're going to switch the actual values. These x values will move down here to the y, become the range. And these y values in the original relation M will become the domain values, or the x values in the inverse. And what we're going to do now is graph that. And there we have that. And we're going to graph the inverse of this, which is going to be the first ordered pair -2, -1. The second ordered pair -1 and 0. The third ordered pair -1 and +1. And the fourth ordered pair -2 and 2. Now, using the vertical line test on the second graph, you can see the inverse in orange is not a function because it does not pass the vertical line test. That means this value of -2 in the domain is paired with two different values. So that does not meet the criteria for a function. But if we look at just the original function and using the vertical line test, we do get the one-to-one correspondence. So to answer the last part here, are they functions or not? This one is a function. and this one is not a function. And we really shouldn't have these here, but I wanted to show you something, so that's okay. We'll leave them there. I do want to show you the XY line. If we drop that in here, that's a special line, and that is the y is equal to x line. A pretty important line on a coordinate plane. We can see these two functions are symmetric about the y is equal to x axis. That would be a definition of our inverse. And so that leads here. Using the example 1, you can see that the inverse is the reflection about the line y is equal to xy of the graph of the relation. If a relation or a function is described by an equation in x and y, you can interchange the x and y to find the inverse. So if we have a problem that involves an equation instead of a table of ordered pairs, we can find the inverse of this equation by switching the x and y. So in example 2t, we're going to see how to find the inverse of an equation as opposed to the inverse of a relation in the form of ordered pairs. So I'll just copy down the original equation, y is equal to x squared minus 2. And really all we have to do here is switch the x and the y. We're going to write this equation as x is equal to y squared minus 2. And we'll need to now solve for y. So I'll just rewrite this equation as y is equal to y squared minus 2 is equal to x. And continuing to solve for y, add 2 to both sides, giving y squared is equal to x plus 2. And at this point, we need to take the square root of both sides, which will give us y is equal to, now when we do this, we're going to concern ourselves with both the positive and the negative square root, because that is the inverse. We can think of this as two halves of an equation, each which would make a function, but that's another topic for another day. Here we have just found the inverse of y is equal to x squared minus 2 by switching the x and the y's, or the domain and the ranges, and then solving for y. This has been Mr. Pi talking about inverses of functions.